Relative strength index is a bounded oscillator that measures a stock's price trend's strength or weakness. 14 days are commonly used for its calculation. For full reference, I recommend that you read Veles Wilder Jr., New Concepts in Technical Trading Systems, published by Commodities Magazine, now Futures Magazine, in 1978. Its calculation follows these steps. A. 14 days average gain and loss. 14 days average gain is equal to the sum of gains from the last 14 days divided by 14. 14 days average loss is equal to the sum of losses from the last 14 days divided by 14. B. 14 days relative strength calculation. 14 days relative strength is equal to the average gain divided by the average loss. C. 14 days relative strength index calculation. 14 days relative strength index is equal to 100 divided by 1 plus the 14 days relative strength. Great. So let's go back into our Python PyCharm IDE so that we can study relative strength index with greater detail. Excellent. So here we are back within our Python PyCharm IDE. In this lecture, we'll be working within relative strength index code file. If you have any questions about its setup, please go back to section 1, Stock Technical Analysis Data lecture, where all of that explained with greater detail. So as all of these are meant to be standalone type of files, first we import our packages, NumPy as MP, Pandas as PD, Matplotlib as PLT, and Talib as TA. Then we proceed to do our data reading by default by creating SPY data frame equals PD or pandas.read_CSV, the path to the corresponding file with the data, which is right here in our data directory, which includes CSV or comma-separated values, index column as dates, and we parse those dates as true. Then we proceed with our technical indicator calculation and its chart. For our technical indicator, we create its new column within our data frame, and we use TA or Talib's .RSI with capitals for relative strength index. We provide NumPy as array close prices. Time period for its calculation is 14 days. As mentioned, this is time period commonly used, but you can adjust this according to your needs. Then we have the technical indicator chart. Fig1, AX for axis equals PLT subplots, two of them which share the x-axis as true. On the first of them, at position 0, we're going to plot close prices with their legend located at the upper left. On the second chart, located at one position, which is below the original close prices, we plot our technical indicator as oscillator, which is relative strength index, colored in green. We locate its legend at the upper left, then we add a superior title to all the subplots, which is SPY close prices and relative strength index RSI for 14 days, and we show the chart. So let's proceed to run the code by clicking the right button on the mouse and scrolling down into Run Relative Strength Index. So we have our chart right here with us. Let's make it full screen. It needs to be done manually because of the screencast right here, all the way to the end as well and to the bottom. There we are. So we have SPY close prices and relative strength index RSI for 14 days. This chart corresponds to those close prices in a blue solid line, and at the bottom we have our technical indicator. Both of them share our horizontal date axis from the beginning of 2016 to the beginning of 2017. Here we have our technical indicator, which is our oscillator colored in green, which corresponds to our relative strength index. Excellent. So let's close this chart and also the next ones. Excellent. We'll study all of them later on. So now that we've finished studying our relative strength index, it's time to continue with the next of our leading type of technical indicators. In this case, we'll be studying our stochastic oscillator, and that is going to be our following objective.